Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on September 9th, 2025, just yesterday. This paper shows that a vision language agent can learn rich, multi-turn exploration and keep improving as it takes more turns, scaling to tens of steps on tough visual search tasks. The paper is titled Mini-o3, Scaling Up Reasoning Patterns and Interaction Turns for Visual Search. And the implications for model training are quite significant. In short, the system pairs a hard visual search dataset with cold start trajectory synthesis and an overturned masking reinforcement learning tweak, unlocking longer, more diverse reasoning that beats prior open models. Also, the authors shared an official GitHub with everything you need. You get install steps, requirements, and a pip editable package, plus pre-trained checkpoints on Hugging Face, SFT and RL training scripts with VLM, evaluation instructions, and example reasoning traces. There are configs, tests, Docker files, and docs, all under an Apache 2.0 license. Alright, Figure 1 shows that letting the agent take more interaction turns boosts accuracy on tough visual search, which signals a true test timescaling effect. The left panel plots accuracy rising with the allowed turn limit, so deeper exploration steadily helps. The right panel breaks down correct answers by how many turns they used, showing many successes come from longer trajectories. Overturn masking matters because the variant without it plateaus, while the full method keeps improving. So Figure 2 illustrates how the agent reasons through a hard visual search by iteratively cropping, observing, and revising its plan. The sequence shows 11 turns that include trial and error and backtracking, which means the model explores different regions until evidence appears. The agent updates its thoughts after each observation, so the actions become more precise. The final turn extracts the correct text below sinker pictures, demonstrating that deeper interaction leads to success. So, Figure 7 explains how overturn masking stops the training loop from punishing long but truncated attempts. Overturn means a response ran out of turn budget or context, which often happens when exploration goes deep. The pipeline keeps the reward normalization, then multiplies each advantage by a completion mask that is 1 for finished answers and 0 otherwise. This simple gate removes negative gradients from incomplete traces, so the agent no longer learns to answer too early. So, Table 1 makes the headline concrete. The method tops open baselines across diverse visual search benchmarks, because longer, richer interaction turns unlock tougher finds. The table reports accuracy averaged over multiple sampled runs, which reduces randomness from temperature decoding. Mini-o3 leads on Visual Probe Hard, V-star bench, HR bench, and MME real-world with a consistent margin. That pattern supports the claim that multi-turn exploratory reasoning scales at test time and translates into real gains. Wrapping up, 2 takeaways stand out. Scaling the number of interaction turns reliably lifts accuracy on hard visual search, and overturn masking lets reinforcement learning encourage deep exploration instead of premature answers. The broader implication is clear. Tool-using agents can gain test time performance simply by reasoning longer. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.